Hello, everyone. Welcome to today's fun math practice. I am Rina. So today we're gonna explore interval problems together. Let's see the first question. Mary has a plot of land as shown below. The lines indicate the path along and inside the plot of land. We know the plot of land has 5 paths. If we give every point, every intersection a name, we have these 5 paths AB, BC, CD, DA, and AC, each 56 meters long. She wants to plant trees along all the paths so that the trees are 7 meters apart on each path. What is the greatest number of trees she can plant? So most of students have realized that if we want to ensure every single trees are put 7 meters apart, that means first we need to divide every road into equal distance. And also we call the distance, the gap between every two things, as an interval. So on a road which is 56 meters long, if we want to divide it into 7-meter intervals, there will be 8 intervals. Then, if we want to plant as many trees as possible on each path, that's how they get. So we want to plant trees from one end to the other end. So on AB, that is, trees are planted on both ends. So the number of trees should be 1 more than the number of intervals. And on the road BC, we can't plant trees at point B again, but we can plant trees on point C. So it becomes we can only plant trees on one end, 8 trees. The same for CD, another 8 trees. And on the road DA, because we have plant trees on point D and point A, so this time we can't plant trees on any end. The number of trees will be 1 less than the number of intervals. To find the relationship, you can focus on the simple diagram. When there are 2 intervals, there is only 1 tree. That's how we get the number of trees is 1 less than the number of intervals. But for the road in the middle, AC, the same. We have plant trees on both ends, so we can only plant 7 trees. When we want to know how many trees have been planted in total, we just need to add 1, 9, 2, 8, and 2, 7 together, which is gonna be, 39. So this is the answer most of the students have given. That's really great. You have know the relationship between trees and intervals on 3 different scenarios. And also you considered we can't plant trees at the same intersection of any 2 paths. But there is another point. Can we avoid plant trees on the intersection of 2 paths? Because as you can see, if we plant trees on point A, when we consider the next road, like the road AD or the road AC, we can't plant trees at point A again. In other words, we need to plant 1 less tree on the other 2 roads. When we plant trees at the intersection of any 2 paths, it will affect the other roads. So let's see the second case. If we don't plant trees on the intersection of 2 paths, what will happen? Like we avoid plant trees at the intersection. In other words, when we plant trees on the road AB, if we want to plant, when there are only 7 intervals, we need 49 meters. That is enough on this road. So if we plant trees on both ends, we can plant 7 plus 1, 8 trees on each path. First, we didn't plant trees on the intersection. So when we plant trees on the next road, also we can plant 8 trees. And here are 5 roads. So altogether we can plant 40 trees. This is more than 39. In other words, if we avoid planting trees on the intersection of any two paths, at the most, we can plant 40 trees. So the correct answer for this question should be 40. Yeah, actually, this question is not only a tree planting problem, but also it wants us to think out of box. Sometimes we just focus on one thing, but actually, this question we need to consider the road as a whole part. So, have you got it? And in the second question, Jessie takes 12 minutes to go from the first floor to the third floor. How long would it take her to get from the third to the 10th floor? Don't just think in your head, in your brain. It's really tricky if you do that kind of thing. Draw it out, draw a diagram to analyze it. Because some students, when they see from first floor to the third floor, so on each floor, she will spend 12 divided by 3, 4 minutes. Is that true? Let's draw it out and explore that. If this is the first floor, to the second floor, and then to the third floor. Yeah, here are 3 floors, but actually, how many intervals did Jessie spend time on? Because actually, when she needs to climb stairs, she spends time between every 2 floors. We call this as the interval. When there are 3 floors, there are only 2 intervals. So if she spent 12 minutes on each interval, she just spent 6 minutes. We need to divide 12 by 2 instead of by 3. And then let's see if she, yeah, because the question is not start from the first floor. That is from the third floor to the 10th floor. The first solution is you draw all them out. It's not a big number. But if next time that is from the third floor to the 100th floor, so we can't draw it out. That means we need to find the pattern. From the first floor to the first floor to the third floor, here are 2 intervals. So if we start from the second floor to the 4th floor, how many intervals are here? It's also 2. Yeah, if we start from the second floor to the 5th floor, there would be 3 intervals. Have you noticed some pattern? 3 minus 1, which is gonna be 2. 4 minus 2, which is just 2. 5 minus 2, which is 3. If we want to know how many intervals are here, we just need to use the last floor minus the first floor, the starting floor, and we can get how many intervals. So from the third floor to the 10th floor, here would be 7 intervals. For each interval, we spend 6 minutes. Altogether, we will spend 42 minutes. That's how we solve this question properly. So first, as you can see, if you feel confused, draw a diagram to analyze the relationship. Second, if you want to know how to solve this kind of problem, we can list several examples to find the pattern. And then, yeah, we will simplify this question. So that's all for today's practice. Let's explore and enjoy math together. See you next time. Bye bye.